Hello, today I would like to show you the current state of my LDPC research and how you can actually apply it now to decrypt LDPC devices like pen drives, SD cards, micro SD cards, perhaps even SSDs. I've published my research here on this GitHub repository. You can go to this URL and download it. At first, I'd like to give you a short overview of how it actually works, and then I'll show you how to do it in practice. So the first step is to create a pattern image and write it to the NAND flash. The second step is to dump the NAND flash to a dump file. Then the next step is to extract the dump file into an extraction file. You will then send me that extraction file and I will do the parameter recovery on it, and then I will provide you with the parameters that you can then use to decode the dumps that you get from the flash tools that still have bit errors, and get them decoded to get rid of the bit errors, and then you can continue with the logical reconstruction in those tools. So what are the requirements for it? Basically, you need a working donor with access to both the controller and to the NAND flash chip, which has to be wired up to either PC3000 flash, visual NAND reconstructor, or a flash extractor. Any of those tools should be helpful. So the first task now is to run the init pattern tool. When you run the init pattern tool, it will show you the disks that you have attached to your computer, also the main disk where Windows is running on, and you can then select which disk you want and call the tool with the disk you want on. To do that, you need a command prompt with administrative privileges, so you have to run it as administrator. Let's do it like that. And here we have the command prompt. So the first step is we download the tool. You scroll to the top of the page, click on the code link, select download zip file, create an empty directory. I already created an directory for the LDPC research on that computer, and you save it to that file. Then you just open it, you extract it just the normal way, and there we have the extracted directory, and then you can go there. So let's go to the and now we're going there with the command prompt, which has the administrator privileges. So the first step, as we've seen, is to run the init pattern tool. So when we run it, we can see here that's the main hard disk SSD of this computer. And this one is a pen drive that I have attached through USB, which has an SMI controller, it seems. And now we can run the init pattern tool and write the pattern on this physical drive. Be very careful that you do not specify the wrong drive, otherwise you will definitely lose all the data on the drive. So we've selected the drive, we're starting the process. Now, as you can see, it detected the device size with 8 GB, so it's an 8 GB pen drive. It calculates the necessary pattern configuration for it. It found out that the maximum pattern for the maximum data area size for those 8 GB is a 2 KB data area. So it uses that to create the image. In case you would have a data area that's bigger than what it chooses for the device, then you would have to create a image file instead, which is much huger, and write it several times on the, also split it up into several parts and write each part onto the drive, and then do a dump from each of those parts, and then run the recovery from that dump in the end. But we assume now that the pattern is large enough. Okay, so it's creating two patterns. At first it creates the old pattern, which is necessary for the flash translation layer reconstruction, and afterwards it will create the new pattern, which is necessary for the XOR and for the LDPC reconstruction. So as you can see, from time to time it tells us how much it has already written. So at the moment it's at sector 500,000. So it will take approximately half an hour, I think, for this 8 GB pen drive, since it's rather slow on USB 2 to get filled up. It's quite an old drive, and and it will take a while. In the meantime, we have some time that I show you some other things we need. So the next step afterwards, when we have written the pattern to the flash, you then have to use Flash Extractor VNR or PC3000 to do a pattern dump, and then we will do the dump extract relevant. For the dump extract relevant, we will need Perl installed on the machine. So let's head over to Strawberry Perl, and here you can download and install Strawberry Perl on your machine. So you can download it and then just install it as usual. And the second thing we will need later on for the decoding is Python. So we go to Python, and here you can click on downloads, and you can download Python for your machine if you have not installed it already on that machine. So those are the two prerequisites we will need later on. Yes. So if in case you have a device with several planes, then some of the tools that I've seen are writing the planes into separate files. So when you write the dumps, you dump each plane separately, and to concatenate the dumps into one big dump, which can then be processed by dump extract relevant, you can use this command to concatenate them. Then to run the dump extract tool, you have this command line that you have to do. The first parameter is the dump file that you got from the NAND flash. The second one will be the extracted dump file that will be produced by the tool. So you can specify a new file name here. And then we will need a pattern file which is generated by the init pattern tool before. And you have to add that parameter as well. And then it will run and produce the output. Then I will need to simulate the extracted dump file. I will also need the pattern XML file, and I will need a few blocks of dump from the device, and I will also need the geometry information of the device that you have already. So if you have VNR, you can send me your case file, for example, or if you have any other, if you're using any other tool, then please send me the configuration files that you've used to dump the case, or send me a screenshot or something something like that, to that I know about the exact geometry of that device. Basically, I need the geometry information about the page size, about the positions and sizes of data area, SA area, ECC areas inside the pages, and I need the geometry information about the block size and plane size. Things like that are what I need from those files. Okay, then I will produce the parameter files for you, and to then actually do the decoding, you can run the decoder, the dump decoder. You can give it an input file, a dump file with bit errors. You have to give it the LDPC parameters that I will send you. You have to give it a case file. I will show you how to generate such a case file if you do not have one yourself. And you have to give it the output file name where you want the corrected dump to be written to. You can give full paths or just the file name in that directory. Okay, let's switch back to our init pattern, and we can see it's already written more than 1 gigabyte, and it's still working on it. So yeah, we can see it will likely take some more time. Okay, here we can see the case file. This is an artificial case file, which just contains the necessary pieces of information that we need. So here we have the record structure of the pages. We have the data areas, the ECC areas, and the SA areas. We have them 2 times, and we have the exact addresses where they start and stop. Then we have the page size here again, and also the block size over here. So that's just a demo case, not from a real device, but that would be the information that we need. So if you have another tool, you can just use this as a prototype, as a template, and fill in the values that you need and use that. If you have some other configuration files from PC 3000 Flash or from Flash Extractor, then feel free to send me those files and I will convert them for you. Okay, here we can now see that the old pattern, which is necessary for FTL, has been completed, and now that it's starting to write the new pattern. Okay, and now it's done. So we're at the end, and it said we're done writing the pattern. So the pattern is fully written to the pen drive now. The configuration has been written to the pattern XML. Let's take a look at that file shortly. That's this one. So here we have information about which patterns are exactly located in which sectors and what parameters were used for the LDPC patterns, and what's the drive where it was written to. That's all available here. And now make sure that it has been written. So properly eject the drive in case that's necessary, and then please do then dump the NAND flash and continue with the dump extract relevant. Okay, so after you have dumped the files, please run the dump extract relevant tool on the dump file you got from the flash, specify a new file name for the upload dump, then provide the pattern XML and the case file, and then let it run, and it should be relatively fast. I think less than a few minutes approximately to process the whole dump and extract the relevant parts. In case it still XOR applied on the dump, then it will discover that it cannot retrieve all the patterns and then automatically try to discover the XOR key and then rerun the dump extraction with the XOR key. And then at the end it will provide you the upload dump, and it will give you the instructions how to continue using it. If you're interested, I can make a video how to use that as well, but I think it should be relatively self-explanatory. And then decoding the dump. Yes, so please start your engines. Take all the LDPC donors you can find, connect them accordingly, write the patterns on them, extract the parameters, and let's solve LDPC together. If you have any questions, feel free to contact me. You can either use the issues system on the top here and create new issues here if you want them to be publicly visible. Otherwise, you could also reach me directly on HDD Guru with private messages. Okay, if you need any help, just let me know, and have a good day. Bye bye.